right, so today we are going to be talking about transformations. So first off, we're going to have some definitions. First, we're going to be talking about vectors. So the definition of a vector is that a quantity that has both direction and magnitude, or basically the size, and it is an arrow drawn from one point to another. And this you can see there is vector PQ being shown. There's always a few parts to the vector. First off, there is the horizontal component, which is the left, which is the left or right. Give me 1 second while these people join. All right, to you guys that just joined, we just started, so you haven't really missed anything. We're just getting started on vectors right now. Alrighty. So again, vectors just have it is a quantity that has both direction and size, or also known as magnitude, and it is an arrow drawn from one point to another. There's the horizontal component of this, which is the left or right movement on basically, or the x-axis, you can think of it as. The vertical component, which is the up and down movement, and the component form, which combines the horizontal and the vertical movement into a coordinate, basically, which, as you can see here, the component form for vector PQ would be 5, 3. Always the horizontal comes before the vertical. Next up, we have translations. The translation postulate just says that a translation is a rigid motion. So first off, we have draw ABC and these 3 points. And as you can see, it has been drawn here. Give me 1 second. And then to translate triangle ABC using vector 5, -1, it would be something like this. Let me rotate very quickly. Right, because as you can see, the vector 5, 1, what it essentially says, right, is that we are going right, and down 1. So that's what we want to do for all the points. For each and every point, we want to go down, go to the right 5 and down 1. You can always go down 1. You can always go down first and then down or up first and then right or left. It doesn't really matter. You'll get the same results. So as you can see, like for point A, we went down 1 and we went across 5 to get the new point, this. And then we did the same for each of the 3 points to translate the entire triangle over. And then after we get all the 3 points, we can just redraw the triangle like so. Now we're just going to take a quick minute. Can you guys just type in the chat box what the new coordinates of the translated triangle are? So what's the coordinates for A comma, B comma, and C comma? Right. And of course, if you're ever confused or if you have any questions, just type them in the chat box. All right. So the coordinates of the translated triangle would be A comma would be 5, 2, B comma would be 7, 3, and C comma would be 6, -1. All right. Does anyone have any questions on translation so far, like what vectors are, anything like that? All right, I do not see any questions. All right, So translation, the vector, what is the vector used to translate triangle ABC? It would be vector um, -4, 1. Um, as you can see here, because for each of the points, we went to the left 4 and up 1 to get to our new translated points. Same for each of the other points. Great. And then for this one, we can say that the rule is that x, y, when you use it, the vector for -4, 1 to translate it, you do x minus 4 and y plus 1. All right. So now we have reflection, or what is known as the line of reflection. So so as you can see here, like at the line of reflection M here, which is basically what is it called? Y equals 1. The triangle is reflected on this axis, and all angles are the same measure when you reflect it. And this is, and then the reflection postulate just says a reflection is a rigid motion. So as you can see, you can reflect it across, the x, the y equals the x line, or the y equals -x line. Those two are a bit trickier to reflect, but are possible. So you can basically reflect it across any of the lines. If you wanted to reflect a triangle look like this across the y, it would across the y, yeah, it would look something like this. And then what we have here is a glide reflection, which is a translation followed by a reflection. Again, remember, translation is move when you what is it called? When you move a shape by a vector, remember? So for this one, it would first be moved up and then reflected across this line, K. Um, this isn't as important to know. I think what's more important for you guys to know is what a translation is and what a reflection is. All right, next up we have rotation, which is when a figure is turned around a fixed point. So the center of rotation is the fixed point that a figure is rotated around. The angle of rotation is the measurement of the angle that a figure is rotated around the center of rotation. And then here are some rules for rotation. So XY would turn into Y -x for a 90-degree rotation around the origin. XY would turn into -x -y 180 degrees for a 180-degree rotation around the origin. And XY would turn into -yx for a 270-degree rotation around the origin. And obviously 360 degrees, it would just be the same thing because you just rotate it all the way around back to its original position. And then the rotation postulate states that a rotation is a rigid motion. So let's say we have this point 25, 4, right? Can you guys rotate it 90 degrees, 180 degrees, and 270 degrees? And then once you get the new translated points, can you just type your answer in the chat box? will just take another minute or so. And then once you're done, just put your answers in the chat box. All right. I'll go over the answers now. So for the first one, right, since x, y would turn into y, negative x, first what we want to do is flip-flop the two values around. So we would get, first off, we would go from 24 to 4, 25, right? But then we also want to remember the fact that x would turn into a negative. So we would get 4, negative 25. For the next one, we would, of course, as always, write it down here. Start off with 25, 4. This one's a lot easier. You just put a negative in front of both the x and the y, and we are good. And then lastly, for this one, we would first, of course, swap the x and the y around. So then we would get 4, 25. Sorry, 25. 4, 25. But we want to remember that the y value would become negative, so it would be negative 4, 25. What questions do you guys have on this? All right, I do not see any questions as of now. Of course, if you have any questions along the way, please let me know. Next up, getting into a bit of the technical parts, how to draw a rotation. So for example, if we want to say draw a 120-degree rotation around point P, we would first, of course, want to draw a straight line using a ruler from point A to point P, or it can be any of the points. You could draw one from point C to point P, or point B to point P. Doesn't matter, it can be any one of those. You just have to you just choose one point to start it off. Next, you want to take a protractor, right? Line it up against the line, and then find 120. 120, right? And then you would get this new point here. Of course, you want to make sure that the new distance is also constant, right? You don't want to, after you translate it, suddenly like point A is like here, or, it's a lot farther or a lot closer. You want to make sure the distance from P to A and all of the other points still remain constant. So after that, you would write down the new point A, and then you would the C or B, and then you would translate all the other ones afterwards. Does anyone have any questions on translations? Or sorry, not translations, how to draw a rotation. All right. Next up, 1 second. Dilations. A dilation is when a figure is enlarged or reduced in a ratio in relation to a fixed point and by a constant ratio. So the center of dilation is the point in which the figures are reduced in relation to the figures are in relation to, and the figures are being reduced to point C. The scale factor is the ratio of the lengths of the corresponding sides of the image and pre-image. We use the letter K to represent the scale factor. So for example, the scale factor would be CP over CP, sorry, let me just draw it. It would be this whole length, right? Divided by this new length, this shrink length right here. So for this one, in this case, K would equal 12 over 8 or 3 over 2. Can you guys tell me what the scale factor is for the second one? Be careful about this one though. All right. So for this one, you want to make sure that you see that now P CP CP comma the new one isn't the largest length, right? For this one, CP would be 18, whereas CP would be 30. So in this case, the scale factor would be 18 over 30, or um, 6 over, wait, no, let me delete that real quick, or 3 over 5. Just be careful about this. You want to make sure that your scale factor is that the new one, that the newly shrunk or enlarged one is at always at the top, and the original angle or the original size, sorry, is at the bottom. Just make sure of that, and then just be aware that of that difference right there. Let me draw another one. All right. Can you guys find the scale factor for the new one? I know it's not C and P, but it's basically just assume P is just substitute A with P if you want. Yep. So the answer would be 21 over 50. That would be the scale factor. All right. Next up, we have just a code. Let me erase this. Next up, we have reductions. We have reduction when the scale factor K is less than 1, then the figure will shrink. We have enlargement when the scale factor K is greater than 1, then the figure will grow. Dilation with a scale factor of 2 would be, so xy would become 2x comma 2y. So both the points would be enlarged by 2. The coordinate rule for dilations, if there's a dilation centered around the origin xy, then kx, then it would become kx, ky. In a dilation, the side lengths and angle measures are a constant ratio in measurement. Similar figures, same shape but not the same side. So they always maintain the same ratio, which means that they are similar but they are not the same. All right. Today's lesson was a fairly quick one. There wasn't as much what is it called? Like interactive work this time around because it's a lot harder for you guys to like, like write on the board and like graph and like do all of these things. But I will be posting a homework assignment on this stuff, and I highly encourage you guys to do it to get some practice with, all the different kinds of reflections, dilations, and all these different kinds of things. Next time's class will definitely be longer because there will be like more like class, more problems for you guys to work on. This time it's just really hard to like for me to find problems for you guys that you guys could like do do like from your desk or where you're at. Especially it's especially a lot harder if you guys don't have like graph paper. But overall, I'd say when I post the homework, I would highly recommend, taking some time to work on it, practice the dilations, the reflections, the rotations. I will say this isn't the most important part of like the geometry, but this will be useful later on. But I think this is still good. This is still good for you guys to know in a sense, and to kind of have this in the back of your mind when you take, harder math courses, because I think you'll be needing it like later on down the road.